Hi everyone, welcome to another episode of the RavenDB webinar. And in this case, we are talking about a new feature, a new mystery feature for RavenDB. As you can see, this is actually our Java API support. This has been something that has been brewing behind the scenes for the past 3 or 4 months already, I think. And without further ado, I would like to introduce Marcin, who has been the person who has done pretty much all of the work, or 90+% of the work. So, Marcin, tell us about the Java API.
Hello, everyone. Today I would like to talk about RavenDB client for Java, and let's start quickly with an architecture. And this API for RavenDB client requires Java 1.5. We wanted to make the Java API as closer as the .NET.
Marcin, 1.5 or 1.7?
1.7, sorry.
Okay.
1.7. Just to make this API as similar as we can. Of course, we can't provide the identical syntax because Java and .NET actually differs. But to provide for the DSL for querying, we used the query DSL library. And for the JSON, we use a Jackson library. And as a stack for communicating with RavenDB server, we're using HTTP client in version 4.3. And those are the main dependencies. Of course, there are other which are transitive from those three. And we use them for communicating with RavenDB server. Before I start with examples, I would like to tell something about the build process. RavenDB is built by Maven, which is de facto standard with Ant for building Java applications. Right now, in order to build our Raven client for Java, we have to check out and compile sources from the URL that you can see on the screen. But in the future, we are planning to put the artifacts with a client in something called Maven Central, where you can simply download dependencies. It's something similar to the NuGet in the .NET world. In order to use RavenDB client for Java, you simply put this 5-line of codes into your POM XML, and that's it. All other dependencies which I mentioned previously will be downloaded and included into your project. Okay, we can now start showing some code examples. I've prepared it as a test case, and we actually support almost all features that the .NET client has, of course translated to the Java world, and to make it more friendly for Java developers. And of course, very similar to the .NET version, we can create a store. Actually, thanks to the Java 1.7, we can use the construction called try with resources, which is very similar to using construction in .NET. This section is actually simple CRUD operation against the session. In Java client, we also have a unit of work. So our objects are tracked by a session, and when we actually call save changes, all changes will be automatically saved to our RavenDB, which is the same as a .NET client. We don't have to register some entities in some repository. Anything like that isn't required. We simply create an object. We can call store. And when we actually finish storing those objects, we can call session save changes, and with only one request, we can simply put all documents to the server, which is great. And does not introduce round trip time. So I will run example after I describe this test case. Okay, here's how we can load documents using client in Java. We also open a session. We can load a class called person. As we know, the Java has a very weak support for generics, so we have to actually shift these arguments. Without generics, we simply put the actual class we want to load and ID. I actually assigned ID for those two objects previously, just to be able to simply refer for them during the load. Of course, this assertion should not fail because this load will be performed. Another option to load this object is to use the string identifier, which is generated automatically based on the entity name. There is implemented pluralizer, which actually puts the entity name into the plural form, as you can see. Plus, we can concatenate with an ID we saved previously in a John ID variable. Another option to load document. Oh, actually, we have even the Java docs just to ease the developer's work. We can put the list of IDs that we want to load, and of course, with only one request, we can load more than one object. As you can see, we don't have any casting to the actual types because we put it here, so we can easily reference to it. Okay, here is how we can modify documents. We can simply load document, set any property. What's quite curious, it is not a proxy, it's the simple document. We don't use a proxies for it, like in any other solutions like Hibernate, etc. And simply save changes. By doing this, we execute the request which updates John's age to number 50. Okay, here is how we can delete documents. When we load some document, we can simply call delete and pass the entity and save changes. Someone may think that this save changes is weird because we have to also do something and call the save changes. Actually, it's very great, as I told earlier, because all operations on session are batched, and we simply batch them, and of course it gives us the transaction support, because by doing the save changes, this request is wrapped with a transaction, and we get all or nothing. Someone may ask, do I have to load the document in order to delete it? No, we can use the low-level API using a database commands and delete the document by using Identifier. And the second argument for the delete is something called ETAC. It's very useful for the concurrency control and to avoid the conflicts. Okay, let me fire up this example. Okay, I will start the server. Oh.
I think that the server is already started.
Okay, so we start. Yes, you're right. So this test actually passed. I wonder, where do I have? Oh, here is it. And those are requests that are generated during our sorry, test case. Okay, the second one is querying. We also start with initiating the document store, and here's something that may look a bit awkward for .NET developers, but it should look familiar to the Java developers which were using the query DSL previously. Let me open the person object. In Java we don't have closures, so we really wanted to make the type-safe querying without the simple strings, etc., which is more bulletproof in case of refactoring and so on. We mark this entity as a query entity, and it gives information for a query DSL to generate the dynamically object, which is prefixed with a Q, and there is a configuration which is required to generate those entities. And let me show generated entity. Here is it. By doing this, we have an abstract entity and automatically generated, which contains all properties that are available in our original person class. So when we create an instance of this, we can reference to this variable, as you can see in a query, without using any strings. And the query, the first query, actually asks for the people which are 18 all order. We call the query on session. Here is the class that we want to query, and here is the predicate for our persons that we should return. Person age greater or equal 18. This expression is parsed, the query is generated and sent to server, and of course we call toList to return the actual result. The more sophisticated query is right here. We query for person, which name starts with letter M and age is greater than 10. We take only 4 first results and order them by age ascending and name descending order, and put it to list. We can then show those persons. Another query, we actually do the projection or select only the names for children. So query for person where age is less than 18, we select name from the person and put it to list. Okay, let me fire up this, and here we have the one child name is Amy, and the person that we return right here is Martin. Okay, of course we can use some chainings when let's say person or has address. We can go over the address field and etc. And we actually support almost all features that are supported in the .NET version. Of course, the syntax is a bit is different due to the restriction that in Java we can't analyze the abstract structure tree of the expressions. The feature actually, which is the base for implementation for querying in .NET Client. So another very cool feature is lazy loading. We also start with a store. We initialize this store and initialize this query DSL helper, and we query for person. We call the lazy method. As you can see, it is not returning the list of person, but the lazy. It's the same concept that we have in the .NET. The second query, or after this line, Raven is not executing any request. The second line is also the lazy query for the children, the persons which age is less than 18. And right here, there's, as you can see in Javadoc comments, we can execute all pending lazy operations. So after this line, we execute only one query for those two lazy queries. Or we can actually get the value of any of the lazy properties, and when we actually comment out this line and call the lazy persons get value, it will form the request sent to server and return with answers to those two options. When we have the same session and we actually query for document by ID, we know that this document was previously loaded, and we don't have to execute another request. Of course, we can force to check for newer version, etc. But in most cases, you don't want to query the server over and over again and generate extra requests. So it's another usage of the lazy loading. Let me clear the console and run this example. Okay. In the first, we have 3 persons. In the second one, we have 1 person. Now let's look at the request that was generated. You may see 3 requests, but it's actually only the output format. Actually, there was only one request, which is right here. Those two with return status to 0 just inform us that those are 2 requests inside this multi-get. Those first 2 requests are the internal, actually to set up a replication or get the database. So, as you can see, we have 1, 2, 3, or 5 or 4 queries and only 1 request using the lazy loading. So we support this feature. Okay, here's another feature, which is includes. Similarly, as previously, we initiate the store. Right now we have the post object. We told the session to include the comments by the comments IDs which are stored in our post, and we load the post by ID post/1. It gives us an object, and right now in this post we have a comments IDs, and when we actually execute this line to load the comment, we don't generate extra request, because right here we tell the Raven to include all comments, and we have only 1 request. Let me clear the console one more time and execute this example. As you can see, the number of requests is the only 1. Here is it. Queries include comments IDs, ID post/1. Okay, here is another query. Using an index. Before I describe this query, we should look at index. Here's the definition of index, and as you can see, I have to admit, sadly, use a string to create this index, because index in RavenDB are created using the Linku syntax. In Java, we don't have Linku, and it might be very hard if it is not possible to implement Linku. This is why we have to put this index as a string. In the sections like information for the storing some fields, we can use the query DSL as previously. So as you can see, the Q prefix in this variable. and we inform that the comments count should be stored in Lucene index. And we query for the posts, and we select ID title and the comment count, which equals to the actual comment IDs count. So we actually, the main purpose of this index is to get the title and the ID of the post and amount of comments. And of course, this index will be evaluated by RavenDB, so we don't have to every time count the comment IDs. So let's back to the example. Right here, we execute the index against store. We have to do that only once, and this index is created in RavenDB. Let me show you this index. I actually executed previously. As you can see, here's an index definition. Of course, you can create an index using a .NET link in Visual Studio, in the Raven Studio, or using strings in Java. So it's up to you. After we execute this index, we can use it. Of course, we should wait until this index is not stale. The RavenDB have to walk over the records and compute this data. So we have a session query for the post class, and here's information to use the index creator, which is in our case post with comment index. And again, we don't have some strings. Of course, we can use strings for the index name, but of course we can use the classes just to avoid strings as much as we can. Plus we can supply some extra condition. We want to query for posts with the exactly 2 comments. Here's information for the API in which format we should return an answer. Because our post has the following fields. It has ID, title, and the comment IDs. So we don't have a place where we can put the count. This is why we can define the entity to which the result should be mapped. And it is post with comments count. As you can see, there is a property for holding the comments count. And we execute it, and that's it. Of course, we can actually customize this query and tell to wait for non-stale results. By doing this, we will wait until the server will analyze all documents, and we make sure that we get the non-stale results from RavenDB server. Okay, let me clear the console and fire up this example. And there we have the comments count. Of course, we have 2 because we requested the post with 2 comments. Here is the output for our RavenDB server. Okay, and that's it. Here's an index, and here are the sample data that I was using during this webinar. We had the comments. The one post has 2 comments, and the second one has only 1 comment. And I think that's it. So I'm waiting for the questions.
Okay, so while anyone on the webinar, please ask some questions. And while we're doing that, there are some questions that have been asked by Mercia. And the first one is, why are we using Java 1.7 and not 1.6? Specifically because of Android support that seems to be stuck on 1.6.
The Java 1.6 is quite old, and actually we don't want us to start with Java 1.6, and in Java 7, we have tried with resources construct, which actually give us an opportunity to easily manage the resources. And actually, when we follow this convention, we have the very clean code, and that's it.
Okay. Okay, we looked at how to create indexes. That's fine. So the next question is, how complete is the Java client so far in comparison to the .NET client? 50%, 75%, etc. Yeah, go ahead.
Yes. Actually, we have implemented all features that we could. Let me quickly go over the list of features that we have. We have, of course, the main, the basic CRUD operations, the lazy loading, querying for DSL. We have a support for changes API, the bulk insert, the spatial indexes, and I don't remember correctly if there are features that we do not support. Of course, this client has a beta status. We are working on the performance and the stability of this release. So, of course, we try to write the test. Currently, we have over 500 of test and coverage at the level of the 70%. So we are working on the stability. All features are already implemented.
Okay. Next question. Okay. How about query statistics? Java doesn't have notion of how, so how is it handled?
What do you mean by query statistics?
After the query, put a dot. Is there a statistics method there?
Okay. Let me, after the query?
Yeah.
Okay, let's see what we have. Let's say we want to query for the person class. I think statistics. We have such feature. Actually, it's work like this. We have to create the
Reference of Raven query stats. Yeah.
Oh.
Okay, so the answer is that we're using a reference
Raven
of
query statistics. We can Raven query statistics.
And effectively, what we're doing, we are faking a
output parameters.
Yes, exactly.
So we have the statistics support.
Okay.
And after this query will be executed, we will have the statistics in this variable.
Okay, great. Now, Hanan Bronstein is asking, will there be support for async? And Martin, unless you've done something I'm not aware of, there is no support for async. Is that correct?
Yes, we don't support async processing because right now it's not very common in Java. Even the changes API, which is very async in the .NET client, we have the synchronous version, but of course we start a new thread, especially for the changes stream, and in the main thread we actually run this application, and in the second thread we consume the changes from the changes API. The same thing is for the bulk insert. We also start a new thread, especially for querying the requests from the output query, and in the main thread we store documents. So right now we don't have a support for async, and features that was async in .NET are synchronously processed in Java.
Something about that. Async in .NET is really a part of the major part of the scene. Is very easy to use. In Java, there are relatively few full async API, and the stuff that we're doing, moving processing to a background thread, in many cases, is much more common. We have a question from Khalid. Are there any other languages in the works, JavaScript, Ruby, Python? I don't want to answer that at this point in time. I can say that there probably won't be anything major announced for 3.0. Nabil is asking pretty much the same question. Is a Node.js or JavaScript client planned anytime soon? There are already existing Node.js clients. I know they're not full and they're not complete, but as I said, we have plans for doing more things in the future. The Java version is what we're going to have for 3.0. Post 3.0, there are going to be more things. John Skeet is asking, what are the minimal steps to use RavenDB from a Java web application?
Okay, let me show you. Actually, the most popular web framework for the web is Spring. The build is using Maven. We simply put this dependency in our project. There is some configuration for the source version, and we have to put this magic code to generate the classes that are annotated with a query entity to generate these versions with Q, just to be able to don't use the strings in queries. And of course we have to define the bin, which is the store, because store is created only one time per application life, and that's it. We can get this from the context attribute or the Spring application context. We can auto-wire the store and execute the sessions, and it's quite simple, and it allows actually to very quickly write the BAO layer, because as you can see, you can simply put the entities and that's it. No SQL to insert into a person where blah blah blah.
Okay. Here's another question from Khalid. You mentioned Android. Is your aim to run RavenDB on mobile devices other than Windows Phone? Why not push mono? Khalid, this is a complex question regarding how to handle that. We had done some work to run both on, we actually have working version of the RavenDB client running on mono for Android, and we have a working version running on iPhone, mono for iPhone, and we had a version running on Windows Phone, and pretty much there weren't any people who really wanted to use that. I think that the number of people who actually wanted to use RavenDB on mobile devices are literally two. One of them was a customer that asked for that. So I put Daniel on doing that, and he ported RavenDB to mono for Android. After that, Daniel used it for a personal project that he was doing, and that was about it. So mostly it's about people not actually requesting that. So that's it. We have a question from Matt Johnson. Does it have support for extension points such as client-side listeners?
Such as what?
Client-side listeners. Document store listeners and its friends.
Okay. The great thing where we can actually is a document convention. And here we can actually set the same thing as we can do in a .NET client. Of course, we don't have closures in Java. So as you can see, for instance, for the find type tag name, we define the interface or actually implement some
anonymous interface.
Could you repeat?
No, sorry, anonymous class. You're correct.
Yes, yes, yes.
I keep calling it anonymous interface for some reason.
Yes, and in Java 1.8 we will have closures, and such interface will be called the functional interface, so we will be able to easily replace it with a closure. But the original question that you asked was
Listener.
an option. Yes, I don't remember it is in
Register listener it's supposed to be.
I don't remember where it was. Okay, let me quickly find, or maybe in session.
No, it's on store.register listener.
So it looks like we don't have.
Yeah, I don't think so either. Try searching for a class called document store listener.
Document
Store listener. Here we go. Here they are.
Oh, here is it. So we have it. Let's find we're actually using it. Here is it. Listeners, maybe I didn't expose it.
Yeah, that's more
bugs, but we have support for document listeners.
Okay.
As you can see. The register listener. Oh, weird.
I think it might. Okay, it's document listener versus the iDocument listener versus document listener difference.
And maybe I have to.
Yeah, change.
Document store.
Yes.
DS. Oh, here.
Yeah. Yeah.
Good to know.
Mm-hmm.
So
Okay.
we have support, as you can see, for listeners.
Okay. I think, guys, in general, I think that you will find that pretty much all of the features that you're used to from the .NET world are still there. John Skid is asking, is RavenDB 3.0 server still Windows only? The short answer is yes. The complex answer is that we're going to be able to run without any Windows dependency. It's just that we don't have the time to do a proper testing and running, making sure that that this is actually stable and working on Mono. The last time that we tried, the Mono compiler couldn't even compile the RavenDB source code base. So that's something that we're going to have to worry about it when this happens. Okay, another question from Matt Johnson. With the .NET client, many issues have been found and fixed around query parsing and serialization. Are you looking closely at those areas in the Java client? Does it have an embedded JSON serializer like we embed JSON.NET?
Actually, I was trying to rewrite this code and look at the test cases that I found in the .NET client. So in the Java, we have almost the same test cases. So I remember that there was a few bugs related to, let's say, the cultures. Like in Poland, we have the periods to separate digits instead of dot, and things like that was tested. And of course, they may be some other bugs in this code, but as I said, it's a beta, but we have a lot of tests and we are trying to make it as stable as we can and bug free.
Okay. Khalid asks, in your mind, who is this Java client targeted toward? Enterprise devs? And that's actually an interesting question, mostly because literally about half an hour ago, I got an email from a customer saying, I want to use RavenDB in more locations, but they needed to support Scala and Node.js. My reply was, go watch this webinar. You'll probably see some things that you like. I think that this this Java client gives more people access to RavenDB. I think that this is especially true when you can start plug RavenDB into your application in an incremental fashion. I've talked about the ability to have RavenDB as a persistent view model cache. I think that a lot of the features that we offer are relevant in the Java world. Admittedly, it slightly sucks having to write indexes as strings, but beyond that, and given the limits of what can be done in the Java language, I think we have done quite a bit to get things working. And I don't see a reason why you can't start a new Java application with using RavenDB. So hopefully it will have broad appeal. Certainly if you have a company that is already using RavenDB and you want to be able to use it in additional projects, the natural extensions for us is people who already know RavenDB, have used it in the .NET projects, and now they have a Java project or a Scala project, and they still want to keep using the database that they know and love. Okay. We appear to have, oh no, there are still more questions. Khalid is asking, will Java company be turned off by being forced to run the server on a Windows machine? As far as I've seen, the answer is a resounding no. Mostly because when you start talking about those types of companies and those types of systems, it's very easy for us to say you're going to run it on a dedicated machine as well. At that point, it doesn't really matter. What you're doing, because whatever you're running on Windows or Linux, or that's it. It's a dedicated machine. You use it, and that's about it. Especially because we tend to need less maintenance than your standard database, standard relational database at least. That means that you can usually just fire and forget it and not worry about it. And we have seen several customers that actually this says it would be nice to run on Linux. We don't care on running on Windows. Just give it to us. Okay, more questions, guys. Going once, going twice, and Marcin, thank you very much both for the webinar and for all of the work that you've been doing, guys.
Thank you so much.
Yeah, guys, in the next few weeks, I hope to have mystery features number 4, and hopefully soon after that we'll have we start doing unstable releases of RavenDB. So thank you all and goodbye.